Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This question is an important application of trigonometric polar form. This question is from my practice book. Question 11 part 1. Find the roots of this quadratic equation. This is a quadratic equation with real coefficients. Therefore, the roots of this equation will be conjugate. Here is the solution. By using quadratic formula onto this equation, we have these two answers. And both the answers are conjugate. Part 2. State the modulus and argument of each root. This is very simple. We all know how to find modulus and argument. Modulus of this complex number is 2, therefore modulus of its conjugate will also be 2. Argument of this complex number. This complex number is in second quadrant, therefore its argument must be pi minus alpha, and alpha is tan inverse 1 upon root 3. So the answer is 5 pi by 6. And the argument of its conjugate must be minus 5 pi by 6. Because z steric is the reflection of z in real axis. This is here. Part 3. Showing all your working, verify that each root also satisfies this equation. Means these two roots. There are two methods to prove this. This is the first method, the direct method. You have to substitute this root into this equation. But this method is very lengthy and complicated. You have to use binomial theorem to expand this expansion, which is very complicated. So don't use this first method. Use the trigonometric polar form to prove that this and this is the root of this equation. Now, first write trigonometric polar form for power 6 because you have to prove this equation, z power 6. This is the trigonometric polar form and this is the trigonometric polar form for power 6. Now we just need to substitute the value of r and theta here and here. This is r and this is theta of this complex number. So by substituting 2 here and theta here and here, we have this equation. This will become 64. This 6 and this 6 will be cancelled, and cos 5 pi is minus 1 and sin 5 pi is 0. Hence shown that this is the root of this equation. Now we have to do the same thing for the conjugate root, for this conjugate. The modulus of this conjugate is 2 and argument is minus 5 pi by 6. Now we just need to substitute r here and theta here and here. By simplifying this and this, we have shown that this conjugate is the root of this equation. I hope this lecture will help you to understand the application of trigonometric polar form well. Good luck and Allah Hafiz.